everyone, Miss Meek here, and today we are going to talk about solving prediction and comparison problems, aka proportions. Proportions are one of my favorite things that we learn about when we talk about ratios and rates and all of that. They are very similar to ratio tables, so if you liked our ratio tables, you'll find that these are very similar. There's just no table involved. So we're going to go ahead and jump in and start with some very simple problems and then work our way to some more difficult problems. So first of all, proportions are literally two ratios or rates that are equivalent and we're missing a piece of them. And so instead of plugging them into a ratio table and doing it this way, we can set them up as fractions and we will set them equal to each other and determine what that missing piece of information here is. Now, sometimes that missing piece of information is represented by a box, like on these first two problems. And then sometimes they're represented with letters, like we see here on our second two problems. We see that letter X. Now, don't be intimidated. That is called a variable, and variables are just there in place of numbers that we do not know what they are. So that X literally just means, hey, I don't know what you are, so I'm going to put a letter there instead. Okay, and we're going to solve for X. So that way we know what number is supposed to go there. So don't be alarmed if you start seeing letters on your proportions. That just means that there's a number we don't know, and we're going to try to figure out what that number is supposed to be so we can get rid of that letter. So let's go ahead and start solving some of these. First of all, these are just like ratio tables. So if you do not remember what ratio tables are, please check out that tutorial video on my YouTube page. It is really great and explains how ratio tables work. It is the same idea here with proportions. Our whole goal is trying to make that 2/3 rate equal to this other rate that has a 15 in the denominator. But we're missing a piece of it. We're missing that top numerator. So what we're going to do is we're going to ask ourselves, what do I do to 3 to make it become a 15? Well, to get 3 to become a 15, I have to multiply by 5. Well, if I multiply by 5 up here as well, I will get the equivalent ratio for that 2/3. So 2 times 5 is 10. So my missing number up there is a 10. So my equivalent ratio that I was looking for was 10/15. Okay, let's take a look at number 2. On number 2, again, I want to look at the top row here because I have two numbers next to each other on the top row, and I have a missing piece of information down here. So my bottom row right now is not super helpful to me. Okay, so I'm going to ask myself, what do I do to this 4 in order to make it a 24? Well, 4 times 6 gets me that 24. And if I do the same thing on the bottom, multiply by 6, I will have an equivalent ratio in the making. So 5 times 6 is 30. So that missing piece of that ratio is 30. It's supposed to be 24/30. Now, again, guys, we can have X's represent our boxes as well. X just stands for a number I don't know yet, okay? So please do not be intimidated by it. Again, I'm going to ask myself, what do I do to this 7 to make a 42? Well, I'm going to multiply times 6. And then I will do the same thing on top. So 3 times 6, that is 18. So my X is going to equal 18. That missing number there is supposed to be an 18. And then on our last one here, again, what do I do to 10 to make it a 60? I'm going to multiply by 6. And so I'm going to do the same thing on the bottom here to get that equivalent ratio. 13 times 6 is 78. Let me double check that math. Yep, 78. So my X right here is going to equal 78. Now, please do not be alarmed. Sometimes you will also use division. So, for example, bonus question here. If you had something like your box was over here and you had a 14 and you were trying to work backwards, okay, let's see, 28. There we go. And let's do 4 up here. Okay, so if I'm trying to work backwards, this is a bonus question right here for y'all. What do I do to 28 to make it a 14? We always move in the direction of our box. So our arrows always point in the direction of our missing number. I never work the other way. So what do I do to my 28 to get a 14? I divide by 2. And so I would divide by 2 up here, and I would get a 2 in my box right there, okay? So again, you can use division. It is multiplication and division. And again, my arrow is always pointed towards the thing that I'm solving for. So I'm always working in that direction when I'm trying to figure out my missing pieces here. All right, let's go ahead and take a look at some harder questions. So these questions, as you can see, look, nothing times 12 is going to get me to 40. So actually, when that happens, just like when we did our ratio tables, we had to divide first to get nicer numbers that we could then multiply up to 40. So for example, I am going to divide this fraction by 3. When I do that, I get an equivalent ratio 4/5. Now what's really helpful about that is now I do know something times 4 that can get me to 40. It's 10. And so I'm going to multiply that bottom number by 10 as well. And so x is supposed to equal a 50. So again, if you cannot figure out what can I multiply 12 by to get to 40, well, that's because there's nothing that works there. So I'm going to have to simplify this first ratio here, this first fraction, to get nicer numbers that I can then multiply up to 40. So this is just like our ratio tables where we would have to divide a little bit first to get nicer numbers, and then we could multiply or do whatever we needed to get the answer that we were looking for. Same thing here on number 5. 30 divided by nothing is going to give me 9. Like, it would have to be a decimal or something. So instead of fretting about that, I am going to divide this first fraction here, this first rate, by 10. And when I do that, I end up with 2/3 equals x/9. I now know a number that I can multiply times 3 to get to 9 like I want. And so I'm going to multiply that top number as well. And so x is going to equal a 6. So again, I could not get 30 to equal a 9. All right, I couldn't get a 30 to equal a 9 right here. And so all I did was simplify this first ratio here, and once I did that, I had some friendlier numbers that I could then multiply to 9. Now, one other way we do have to know how to apply ratios and proportions and all of this too is word problems. So here's an example of some word problems. It says the Meeks drove 144 miles in 10 hours. This right here is our initial rate. This is really important because this initial rate tells us our labels. We have miles and we have hours. And yes, you do need to write your labels because when you set up a proportion, one of the biggest, most importantest things ever is to make sure that your numbers are lined up correctly. And so I have to write my labels. To do this first ratio here, I have 144 miles. So that's going to go on top where my miles are right here. And then I have 10 hours. So that is going to go on bottom, which is my hours row. So my hours row is on the bottom there. Let's keep reading. At this rate, how many miles will they drive in 30 hours? So again, for my second fraction here, I am missing my mile number. I don't know what that is. So I am going to use the letter M for my missing miles. And I want to know how far they will drive in 30 hours. So I'm trying to figure out what M is. And M is the distance I will drive in 30 hours. So this is going to be my proportion. Everything is lined up. All of my miles are on top here, and all of my hour numbers are on bottom here. That's very important. Now we're going to go ahead and jump in and start to solve this. So what do I do to 10 to make it become a 30? Well, I'm going to multiply times 3. And then I'm going to do the same thing on the top here. So over to the side, I'm going to do that scratch work. That's 144 times 3. Okay, carry my 1. And so I end up finding out that it is going to be 432 miles. So my final answer to answer the question that the problem asks is that the Meeks will be able to drive 432 miles in that 30-hour time frame. All right, guys, so that is proportions. That's how we solve proportions. I hope that this helped clear up any confusion and hopefully not stress you out about starting to throw some letters into our math. It's really exciting. It just stands for a missing number. All right, well, I will talk to you later. Bye.